Okay, chicos, this lesson is about perpendicular lines. If you remember, this is a review, we talked about previously about parallel lines. And parallel lines, if you remember, have the same slope. Do you guys remember that? The slope of the first line is the same as the slope of the second one. Why? Because remember that slope tells us the direction of the lines. And in this case, the lines, if they are parallel, they're going the same direction. And that is why they never touch, because they're going the same direction. So the slope of the first one is the same as the slope of the second one. Okay, and this is where we did the line 1 and the line 2, and we found the slope of the first one, and then with that one we use the same slope for the second one. Okay, so today we're going to learn about perpendicular lines. And if you guys remember, perpendicular lines are the lines that touch in one point, perpendicular lines touching one point with a 90-degree angle. Okay, so they look like this. This is our coordinate plane, and we probably have like a line here, and then there's a perpendicular line that touches in one point here, and they form 90-degree angles. Okay, now the relationship here of the slopes is going to be that they are the negative reciprocals. Okay, so M1 equals the negative reciprocal of M2. Okay, so we have to remember what is a negative reciprocal. And maybe so you are starting to remember these things from previously that you've learned it before. Negative reciprocal is whenever we change the denominator for the numerator. And a negative is like an opposite. Okay, so if we have, for example, let's give an example here. If we have the fraction negative 1/5, the negative reciprocal is going to be 5 positive. Okay, we change the denominator and the numerator, and we also change the sign. If the fraction is, for example, positive 2/3, then the negative reciprocal will be negative 3/2. So in this case, the first number would represent our M1, our first slope. And once we find the first slope, then we have to make the two changes to get the second slope, which in this case will be 5. Or if the first slope is 2/3, then we have to do two changes, the change of sign and also the reciprocal to find the other slope. Okay, so let's do an example so that you guys know how to do this exercise. It says, find the equation of the line perpendicular to the line y equals negative 7/3 x plus 5 that passes through the point that passes through the point um, 0, 0,2. Okay, so remember, just like we did before in our examples of parallel lines, we're going to have two lines. Line 1, where we only need the slope 1. That's all we care about. And line 2, where we have to find the equation, doing all the process. Okay, so this is our line 1. So I'm going to put it here, y equals negative 7/3 x plus 5. What would be the m1 in this case? Well, if you see the equation, the m is going to be this. So that's my m1. And so using that and nothing else, look, notice that I don't need the 5. Using that, I move here the m1, but deciding what would m2 will be. And so what would m2 be? Well, it will be the negative reciprocal of m1. And what is the negative reciprocal of, of negative 7/3? Positive 3/7. And then this also, we know that it passes through the point 0.2, 0,2. So you guys know that if we need equation of the line, we are going to work with y equals mx plus b. And so we just start substituting what we know. We know this is x, y, so that's going to be 2 equals, and then the 3/7 times 0 plus b. Okay? Now notice that 0 times 3/7 is 0, and so in this case, 2 equals b. Some of you get confused by using this 5. You do not have to use that 5 because that's from another line. This is, there are two different lines, and the only reason you need the first line is to find the slope. Once you have the slope, you don't need it for anything else. You completely ignore the line 1, and you just work with line 2. And so my final answer, remember, we always have to write our final answer, is going to be the equation using the m2 and the 2 and the b that we found. And that would be the exercise. Okay? All right, you can try your exercises now from the practice.